The topic that I'm going to cover today is linearization of tree. Now, you see this is a tree and this is just a list. A list is a linear structure because one node is connected with another node. One node connected with another node. The second node connected with the third node. But if we look at a tree, one node is connected with more than one node. So this is a non-linear structure and this is a linear structure. Now when we are talking about linearization of the tree structure, then we are actually trying to understand how we can represent this tree using an array. How we can represent tree using array, right? Now when we are representing a tree using array, first we store the root node, then according to the convention we store the left child, then we store the right child. So first we store the root, then the left child, then the right child. So in the 0th index we store the root, first index the left child of the root, in the second index the right child of the root. Correct? Now let us look at a more bigger tree. Suppose a tree looks like this. How will we represent this tree in an array? Again, the first index, that is the 0th index, will have the root node, then comes the left child, then comes the right child. Now after that we start with the left child of B, that is we store D, then we store E, then we store F, and then we store G. Correct? So these are the index numbers of the array. Now you have to find, now when we are doing a program or we are coding on this representation of tree, you see this is not a linked list representation of tree, this is an array representation of tree. We are implementing a tree using an array. So when you are coding using this implementation of the tree, you need to know where the nodes are stored so that you can code. Correct? Okay, so let me take this example and explain to you how we will be able to identify the roots and its corresponding left and the right child in the array. Now you see over here the right child of B is null, right? So let us find out how do we represent this tree in an array. So we are representing this tree in an array. Obviously the first index will have the root, then B, then C, then D, then over here it is a null, so you have to put this null over here, and then F and G. Now this is index number 0, 1, 2, 3, 4, 5, 6. Now this is the root, this is the left child, this is the right child. Now you see over here the root is at index number 0. When the root is at index number 0, the left child of the root is at index number 1. In the array, the left child of the root has been stored at index number 1 and the right child has been stored at the index number 2. Now come to this portion. This is the left subtree of A. This is the left subtree of A. And which is the root node of this left subtree? The root node of this left subtree is B. So where is B? B is stored at the index number 1. And so when the root of the left subtree is stored at the index number 1, the left child of that root node has been stored at index number 3, and the right child, which is null, that has been stored at index number 4. Correct? Right subtree. C is the root node. Index number of C in the array is 2. Left child of C is at index number 5 and right child is at index number 6. Now if you look at this table very carefully, you will see, you will be able to identify a relationship. You see, if all the roots are considered to be at ith index, then all the left child are at the index 2 into I plus 1, and all the right child are at the index number 2 into I plus 2. You see, this is 0, I value is 0. 2 into I plus 1, 2 into 0 plus 1 is 1, 2 into 0 plus 2 is 2. This I value is 1. 2 into 1 plus 1 is 3. 2 into 1 plus 2 is 4. Right? 2 into 1 plus 2 is 4. This I value is 2. Over here, 2 into 2 plus 1 is 5. 2 into 2 plus 2 is 6. So whenever in an array we are representing a tree using an array, if we store the root at ith index of the array, then the left child is getting stored at the index number 2 into I plus 1, and the right child is getting stored at the index number 2 into I plus 2. So this information you can use to retrieve the left child and the right child of a node if you are coding a tree using an array. Okay, so this is called linearization of the tree. So what did we learn? Linearization means we are representing a tree structure using array. We store all the values one after the other. According to the convention, we store the left child first and then we store the right child. And if a child does not exist, then we store null. Now, it is very important that if the child is not present, you have to store this null. Otherwise, this equation will not work. Suppose I do not store this null. If I do not store this null value and f and g is shifted over here, then my formula will not work and I will not know which node does not have a child, which node has a child, and where that child has been stored. So whichever child is missing, for those missing children you have to put null in the array. Correct? So this is how we represent a tree using array.